Hello everyone and welcome back to another video. And today I finally just do some good old classic overclocking again. The point of this video is to just go out and properly overclock and mod something once again, because it's been quite a while since I've really done that. And what better card would there be to do this with than a GTX 480? Well, to be fair, there's a bunch of cards better than a GTX 480. It's the GTX 480 has a bit of a reputation, and well, it's a really old card. I think this thing launched like 2010 or 2011, so 13 or 14 years ago, and yeah, the standards have a bit changed. This card is known for having very high power consumption and running very hot. This part in particular right here being capable of being used as a grill, which, well, the temperature part is true. The heatsink of this thing is kinda awful, and we'll get into that. But the power consumption part? No. Just no. I've done some pre-testing, and I have my Elmer PMD connected to the card, so I can measure exactly how much power is going into the card, at least over the 8 and 6 pin. I can't measure the slot, but I'll just always assume that the slot draws 75 watts, I'll just add that. So yeah, the card was only drawing 180 watts max, and that was like at full voltage, full clock, maxed out, 180 watts. Yeah, a 4060 will beat that. So, this is not a card that needs a lot of power, not by today's standards. The 480 is very tame, power consumption wise, for today's standards. Like, I mean, not even today's standards. I had a 780 Ti that did like over 300 watts easily, without modding it, or like replacing the heatsink or anything. So yeah, like the 480 was never really a high power consumption card. It just kind of ran hot, and well, the main reason why it runs hot is just the awful heatsink. Like, and it's not because it's a blower. Like the 580 comes with a very similar heatsink, and that heatsink is surprisingly good. If you just max the fan out, yeah, it's gonna be really loud, but that 580 heatsink can keep the card below 60 degrees, even if you max it out. This cannot. This heatsink, even with maxed out fan speed, the card will still climb over 70 degrees. Which, well, isn't 90 degrees, but remember, maxed out fan. It's a blower, it's gonna be a vacuum cleaner by that point. So yeah. And the main reason why this heatsink is so awful is these heat pipes. So yeah, this is not what most blower heatsinks are, which is a vapor chamber. No. This is a regular heatsink with heat pipes and just a regular old fin stack, and then direct contact heat pipes. And these are massive heat pipes. They have pretty big gaps between them, so the contact is just kind of trash. And on top of that, Fermi is an architecture that has an IHS on the GPU. So yeah, like the IHS is not as big of a problem as you would think. The main problem with the IHS is that the contact tends to just be kind of bad for the thermal paste that's below the IHS, and the main thing that impacts is your memory clock. Because Fermi cards, they tend to have a similar thing to some old NVIDIA cards like the 200 series, where your memory clock isn't actually limited by the chips, but the memory controller in the GPU. Because the memory controller, especially on 500 series cards, on 400 series cards, is not as bad. I actually haven't seen that directly on the card I've pre-tested. But it is a thing that tends to happen on Fermi, is that your memory controller is actually the limiting factor for your RAM clock, not the RAM chips themselves. And because the memory controller is very sensitive to temperature, having bad contact and therefore hotspots tends to kind of just ruin your memory overclocking. So deleting the card, running a direct die, or reapplying better thermal paste and putting the IHS back on tends to improve memory overclocking on these cards. It doesn't tend to really impact core clocks. It can get better, but I've had cases where it just doesn't matter if you run the IHS or not for core clocks. Yeah, like the main problem is just the heatsink, because a vapor chamber is just better than heat pipes. Like, it just is. And then there's the fact that these, 4 large heat pipes, well, they go through the fin stack, which blocks airflow. And then there's the awful cold plate as well. That's really the problem with this heatsink. So yeah, the heatsink kind of sucks. So this card gets really hot. And especially the GTX 480 is very, very temperature sensitive. So it's a thing with 400 series, the Fermi 1.0 cards. They are not actually, that exciting to overclock. They still scale, but they scale a lot more like modern NVIDIA cards, not like you typically expect older cards to scale, because these things, yeah, they voltage scale to a certain extent, but at a certain point, which tends to be very consistent, it's around the low 900 megahertz mark for the larger cards like 470s, 480s that use the GF100 core. They tend to just wall, and no extra voltage you shove into them, no extra capacitors you put on them. Well, actually, capacitors could help. We'll get into that in a bit. Yeah, no extra voltage you shove into these cards really helps. And yeah, so like you can max this thing out at like 1.15 volts, 1.2 volts. More than that's not really gonna do anything. It's just gonna make the card run hotter and sometimes even lose clock, because yeah, these things scale significantly with temperature. So yeah, so you just need to throw more cooling at them at a certain point, which is another factor why this heatsink is so godly awful. And yeah. So anyway, I decided to mess with this card anyway, because I have a bunch of heatsinks, a bunch of water blocks, and a phase change cooler I can throw on this. I have a bunch of stuff I can mod on it. I know for a fact that the CHL8266 voltage controller on this has an I2C bus hookup. It's right here. Like, I can connect my Elma EVC to this and directly control the voltage on the vCore VRM, and also things like the switching frequency. So we get some pretty fancy controls over this controller. We don't just do a basic feedback mod, like we could do that. But an EVC is going to be a bit more interesting, because we get very precise control over everything. We won't get control over the memory. This one's just yeah, this one doesn't do I2C. Gonna have to just feedback mod that. But over core, we'll get some pretty good control. And I do wanna also hook up the oscilloscope. And actually, I have hooked up the oscilloscope, because this isn't actually the card I'm gonna run. This is another 480 that I'm just showing because it still has the stock heatsink on it, because in my pre-testing I've already decided that I'm not gonna run this. Instead, here's the actual card I'm running. So it's another reference PCB, like all the 480s have a reference PCB. Getting a custom PCB 480 is actually kind of hard. But yeah, you can see the oscilloscope probe hookup is right here. Just directly behind the core, I put my coax into that, and then I can see the voltage regulation quality. And then on the front, we have my trusty freeze mod water block, and the this is a stock 480 blow-up cold plate for the VRM and memory, because it's kind of nice. I did modify it a little bit, and you can see the middle part has something cut out to make the block fit properly. But yeah, other than that, it's a stock 480 cold plate. This used to be on a different GTX 480, That 480 ended up dying, doing pretty much exactly what I want to do today. Little fun fact, literally all the GTX 480s I own, I bought as broken, and I necromanced them back to life by heat gunning them, which is not a repair. I want to emphasize this. You do not repair the cards by doing this. You temporarily necromance them back to life. Strong emphasis on temporarily, which is exactly why that other card died. And it's also exactly why I can't put the card down like this, because the oscilloscope probe hookup will break off. But yeah, it's exactly why I'm not running this card, because this card has problems. If I remember correctly, the core on this actually clocks better at ambient, which is actually not really what I wanted. But yeah, this thing has problems with getting detected. It sometimes just doesn't get detected. So yeah, bit annoying. But yeah, this one seems to work just fine. I think actually this is the GTX 480 that I dailied for a bit. Yeah, fun fact, a while ago me and some friends were playing a raid in Destiny, and we were making a bet. It's just like, hey, if I get the exotic to drop on the first try, I'm gonna daily a GTX 480 for a day. Anyway, the GTX 480 was surprisingly capable once you just bring the resolution down. And I think it might have been this one. So yeah. Anyway, I should really get into it. We're already at 11 minutes and we haven't even started overclocking yet. Yeah, so this card, it's not really that great at overclocking. Like the core nor the memory, they're not really that impressive. On the stock heatsink, the memory maxed out at 2200, but only briefly. Like, it can pass 2200, but it really doesn't like to. So 2100 is more like what it can reasonably do. And then the core on air cooling, on the stock heatsink, 920. Which is pretty bad. Like I said, 400 series cards are kind of consistent in where they clock wall, so they are all in like the 900 megahertz somewhat range. This one's in the low 900s, so this one's like one of the worst cards, which indicates like it's a higher leakage sample, which means it's probably gonna overclock better once we cool it down, which, spoiler alert, it kind of did already, because yeah, it's kind of bad. But yeah, it got a lot better because I put the stock heatsink off and I put a custom aftermarket air cooler on it, because like if you see, this is a Zotac card, and this Zotac card didn't actually come with the stock blower. The stock blower I put on this actually is from a different card. I have a bunch of GTX 480s. Well, actually I only have these. No, that's a lie. I have 4 480s. Just 2 of them are dead. And the third one that I just showed you is also kind of meh. Only this one is like kind of reliable. But yeah, this is a Zotac card, and Zotac sells these cards with a Zorman VF3000 cooler, I think it's called. It's it doesn't look like much, but again, we've established this thing only draws like 180 watts plus 75 from the slot. It's not much. And it's like a dual fan Axio cooler, 3 slots, and like not that much of it is actual FinStack, but it's more than like the 3-slot Asus coolers have. So the heatsinks, it's kind of decent. It doesn't look like much, but it's pretty good. It keeps the card at like 55 degrees max. That is without the IHS. I did remove the IHS and run it direct at that point. But yeah, 55 degrees. Pretty decent. And the card clocked better. It started doing 940 megahertz at that point. So we're getting closer to like a good 480 territory. And yeah, so we went from like 70 degrees to 55. That's 15 degrees better temperatures. And we scaled 20 megahertz. That's pretty decent already. Like, that's pretty good, considering I can go all the way down to like minus 40 with the phase change cooler. So if we keep going that way, this core is gonna go really fast. Now, I don't think it's gonna keep scaling like that, but it's kind of promising. Because, like I said, like 480s tend to clock well in like the mid 900s. I think the best one I've seen was 960. I may have seen one that did 980, but I'm not sure about that. I have a old Google Docs thing, like a bunch of binning data. Maybe I should just look into that, see if I have a 480 that did that. But I think you wouldn't really ever see anything better than like 960 on a stock unmodified 480. So yeah. But 20 megahertz already from 15 degrees core temperature. Decent scaling, very decent scaling. Like, it went from a pretty bad 480 to like just a slightly below average 480. And then I put the water cooler on. And now the load temperature is 38 degrees. Which, funnily enough, is the idle temperature of my 2080 Ti. Because the 2080 Ti draws like 300 watts easily. And this stays below 200 on the external power. So, yeah. Yeah, so with the water block, the card now passes 960, making it a really good 480, though considering it is on water cooling, you know. And I got a few passes at 966 core. But that is like very bleeding edge. It is not reliable at all, and 970 is like, it's insta-dead. Like, there's no way of even getting through GT1 and Firestrike at 970 core. But yeah, decent scaling so far, with just throwing more cooling at the problem. And then to end the pre-testing session, I threw the oscilloscope tab on the card and wanted to figure out, you know, what's the transient response like? What kind of voltage drops do we get on a stock 480? Now, I know a stock 480 is awful. This might be the single card with the worst power plane ever. I don't really know why, because there's no like major reason why the power plane on this card would be really, really bad, but it just is. I remember measuring just with a multimeter like V-core here and then V-core here, and there was a difference of like 100 millivolts or more, like already, which is kind of like that's a bit much. And I remember probing another 480 with the oscilloscope and also seeing like really bad undershoot. And I think I remember Bullseye also testing a 480 with the oscilloscope and also seeing really bad undershoot. So I tested my 480 with the oscilloscope and saw, again, really bad undershoot. Yeah, this thing is undershooting by like 110 to 140 millivolts, which is bad. That should be like half as much for me to call it like decent VRM performance. So it sucks. Like, thing is, people like to blame the VRM on the stock 480, and yeah, it's not a very great VRM. Once you let this thing run at like 1.35, 1.4 volts, that's not gonna be okay anymore. That VRM will beg for death, and maybe we'll get that today. But the VRM itself, like the MOSFETs, they're not too bad. The controller is actually fairly high end. And like, well, the output filtering is like, it's not that much, but it has a decent mix of like multi-layer ceramics, SMD polymers, and then there's CAN-type capacitors on the front. Like, it has a decent, okay output filter. Like, the VRM itself is fine. The main reason I have these 480s is to turn them into E-powers once they die for good. Because they are pretty decent medium power E-powers once you turn them into them. So these VRMs, they're fine up to like 300 watts. Past that, it gets a bit problematic. But anything that's below 300 watts, pretty decent VRM. And like, unless you push a lot of core voltage into this, it is below 300 watts. So the VRM's not really that bad. Like, it's not super efficient by today's standards, but like, in terms of how much power it can handle, it's fine. As long as you don't overdo the core voltage. So it's really like the power plane that sucks on this card. it's just so bad. Like over 100 millivolts of undershoot, like significantly more. Like at 140. Oh boy. Like I usually run my oscilloscope at 50 millivolts per division, and just running Firestrike filled out basically the entire screen. Because there wasn't just copious amounts of undershoot, there was also equally as much overshoot. I think I saw overshoot to like 1.43 volts, with the core voltage set to 1.2 volts, and it was undershooting to like 1.1. So, not great, not great. Yeah, overshoot on this real bad. Like the VPP was legitimately 300 millivolts. Not very good performance from the VRM here, which is why. Oh god, we're 20 minutes, 21 minutes, and we still have an overclock. This is a long video. You know what? This might just be parts. But yeah, it's this thing needs mods. Like, that is atrocious undershoot. Like, I don't really care too much about the overshoot. Like, oh no, 1.43 volts, but it's just for like a nanosecond. It's fine. The VRM can take that. It's when your average voltage goes that high, that's a problem. Yeah, that undershoot needs to be fixed. So, the point of doing stuff today is to fix the output filter. So I'm gonna be stacking a bunch of can types on top of these multi-layer ceramics here. And then, well, I guess I can stack some for the memory capacitors as well. I don't think I want to put anything directly behind the core, because I have the oscilloscope probe in this area, and just I don't want to do too much to multi-layer ceramics behind the core unless I really have to. So I think I'm not going to touch the backside of the core. I might attach some multi-layer ceramics to like the memory chips. But, well, like, that's the interesting bit about this card. It didn't care about getting the D-Lid. Didn't care about getting better cooling for the memory clock. It still maxes out exactly the same. So you would think that, okay, it's not the memory controller then. But like this has Samsung 1 gigabit eDie. The exact same chips that like clock really, really well on 500 series. And here they just kind of don't. And I don't think that, you know, from... when did the 500 series come out? I think also 2011. Like in that short amount of time, I don't think there's going to be as massive of a jump in just how good this chip performs, because it's the same chip. And the scaling behavior is like the same. It likes being cold, it likes voltage. So yeah, I still think it's the memory controller. I just think that the memory controller on this card doesn't particularly care too much about temperature. It might like more voltage, because the memory voltage on NVIDIA cards, remember, also powers the memory controller. And sometimes that can help. Or maybe it just likes really, really cold, and water cooling isn't enough, and we need to pull it sub-zero with the phase. So that's an option. But yeah. Also, I see, I had once soldered something to the I2C bus on this card already. Huh, interesting. Yeah, I guess I'm gonna reattach that. Yeah. I think that's everything I wanted to say. So, yeah, I think I should... do I remove the block for this, or does the card just kind of sit right? Because now is the point where we want to attach some capacitors to this. Oh, it does kind of sit okay like this. Yeah, because I want to fix the VRM performance. And where's my giant bag of capacitors? Here it is. I have a bunch of them. So, yeah, I don't need to care about not wasting capacitors, because I literally have a bag of 750 of them, and I don't think I've used 100 yet. I have capacitors for days, literally. So yeah, I'm gonna be modding the hell out of this part of the output filter, and see what else I can do to just kind of hope to bring the VRM performance to a better place, because then, the funny thing is, if I can get the VRM performance to go significantly better, we might be in a situation where I lower the voltage to what I ran before, and we can now run higher clocks. Because again, these scale a lot with temperature, and if I can bring the minimums up by a lot, then we can just lower the voltage, get the same minimums, but run at less heat, because now we have a lower average voltage, and then the card might clock higher. So, yeah. And also just EVC, because, you know, maybe we can push a bit more than 1.2 volts. Like, I did technically see scaling all the way up to 1.2, so maybe we can push a bit more. So, yeah, I'm gonna see the I2C bus connection as well, so I can hook the EVC up to this. And yeah, after 25 minutes of rambling, it's finally time for the soldering montage. Alright, so modding session 1 is done for the card. We have an I2C hookup for the EVC so that we can control our CHL8266. No voltage control for the memory VRM controller just now, but I did leave that section like S3 as it goes so that I can still add that later. We have this massive array of 12 capacitors for the vCore VRM. All of these capacitors are 820 microfarads, 2.5 volt rated, and I think 5 milliohm ESR? I don't remember. They're like not the super highest end capacitors you can get, but they were like pretty decent. And yeah, so I also doubled up the output filter. Actually, that's more than double, because the stock one's only 560s, I think. So 3 820s for the output filter on the memory VRM as well. And there's also an unpopulated spot for an SMD capacitors. This is also memory, not core. And I just added one here as well because, like, you know, if the power plant for the core is already awful, then the one for the memory is probably not that great either. And, you know, this empty capacitor patch just kind of, you know, why not? So that the last couple memory chips right here and then also the parts of the memory controller on this end of the die get some better voltage regulation as well. So, yeah. That would be it. The last part would be to find out if I actually soldered the wires for the I2C correctly. I might have to swap them around. I'll just get them out of this tab and swap them around. I'll just put a set of wires in between that just swaps it around. Yeah, because I'm not sure which is SDA and which is SCL. Like, tends to be different. Actually, I have a board view for this card. I could have just checked. Ah, well, too late now. But yeah, so we have a decent amount of extra capacitance on this card. Now we have, in theory, control over everything that is vCore. So, yeah, let's test it. Let's see how the card acts now. Let's see if the awful undershoot is less awful now, and perhaps we can get some higher clocks out of it. So, yeah, let's start in the system, connect the EVC, and see if everything works as intended.
Before we continue, I'd like to thank my sponsor, PCBWay. If you've been following my channel, you'll know that I've been designing and building a 3D printed RC plane over the last couple weeks and months. Part of that design required a very strong and durable landing gear, which would be required to be 3D printed out of materials that are very hard to get right on the FDM 3D printers that I own, which is where PCBWay comes in. To help with my project, I got to use their 3D printing service, and so I got my landing gear design 3D printed out of glass fiber reinforced nylon on their SLS 3D printer, which is an industrial kind of 3D printing that doesn't really exist in the consumer market, due to how large and complex and also expensive the machines are. But the results of such a machine are just astonishing, and after a first round of ground testing, I'm very satisfied with the results. The landing gear held up great and shrugged off everything I threw at it. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. Okay, little post-production addendum here. At 2 points in the next clip, I have some very, very horrible microphone audio. I think the cable might have slipped out a bit. I don't really know what happened, but it caused some very, very nasty interference noise. I tried my best to get rid of it, but as a result my voice sounds like I'm inside of a pipe using a Nokia 3310. So it's not great. You can still make out what I'm saying, it's just not really pleasant to listen to. So I'm sorry for forcing you to go through this. It does get better, and the rest of the video is completely fine. It's just that I didn't want to cut this out because it's supposed to, be a live benching sort of session. So yeah, just be aware this next part has kind of horrible audio for a bit. So just so you're not surprised. And with that, back to the video. Right. Well, I guess we're getting an even worse case than before. That would be why. Yeah, I messed with the I2C. Like, some cards, especially CHL controller-based cards, they tend to be a bit buggy. Including this one, where like, you know, the I2C with like the EVC window will just freeze. And it will no longer accept commands, and you just need to reset the EVC, and then you can apply like one command, and then it freezes again. Not that great, but yeah, I disabled the load line just to see if it applies, because I can see the voltage change on the oscilloscope pretty quickly. Just to make sure that it works. Alright, GT2 is coming up. And this data is not gonna be representative, like not comparable to before. I mean, I'm gonna have to power cycle the system and do it that way. But worst case, you know, without LLC, yeah, it's we have an average of 1.3 volts and minimums of 1.16. That's still 140 millivolts. And our maximums went up to 1.48 volts. Now, to be fair, yeah, that is without LLC. And actually, I'm gonna stop the test now and hey, I said stop. And shut this thing down. Disconnect the EVC so the controller resets. And then run it with, you know, just with the EVC disconnected. Just there we go. Gone. Turn back on now. And now the EVC is not going to be messing. Yeah, now you can see that it's frozen because like it's not updating. Let me see. EVC reset. Still not updating. It's just, yeah. I guess it broke. Yeah. Fancy. Oh yeah, because we just disconnected it. Got that. I'm stupid sometimes. I can't see anything on the EVC. Is it perhaps because I disconnected it? Anyway, so still the same. It's doing the same clocks, same voltages, same everything. Let's run it again. Just to see if my capacitors did anything. So far it doesn't look super good. I really kind of hoped I would see at least something, because like that is so much capacitance we just added to vCore, like 12 capacitors. Like they're all CAN types, and my soldering isn't the best, but like 12 times 120 microfarads, that is more than the entire stock VRM. That's just now on there as well. You know, you would think this does at least something, but apparently not. Well, let's see. Without LLC disabled. Yeah, now the average is at like 1.26. Which is kind of surprising because it's set to only 1.21. But we're getting 1.26. Even 1.27, like behind the core. Like it shows you like how much voltage actually still gets lost from the BGA and the substrate and everything. I mean, it's similar with CPUs through the socket. So here's GT2. Don't crash, please. I want to see the minimums. Realistically, I'm expecting to just see no change or very slight change. and it's gonna get worse once we keep increasing the core. Yeah, like, we could put stuff directly behind the core, but I really don't want to. Especially after seeing these results. I think that's just not really fixing this power plane. Like, it's just horrible. So I guess the next plan effect. That is a really low score. It's doing the correct clocks, though. Why is that score so horrible? I saw this do like 4,900. Huh. Well, that's for me to figure out later. What was I saying? Yeah, so I guess the plan of action is to... Well, first I want to figure out if, like, it clocks higher now. Like, if those minimums, especially also the capacitors I attached to the memory, if that translated into any better overclocking. So I want to test that. So, like, I'll make a quick cut and then be back with, like, oh, hey, it's better now, or, oh, hey, it didn't change. And then... Yeah, as last part of the video, I guess we're gonna take the phase change unit, strap it to the card, and then just go like, yep, it is cold now. And I guess I'm just gonna push as much voltage into it as I see fit and see where it goes. Like, if I remember correctly, it's gonna be like mid 1000s. Like I said, these cards are not really that exciting in terms of scaling. 500 series is much better. But judging by that other 480 I had called, it's I don't think it's gonna do 1.1 gigahertz. Like, I don't think it's gonna do that. Anyway, yeah, so I'll do some testing. Figure out if maybe the capacitor mods did something to just help the card as is. And then we'll chuck the phase change on it and see what happens. So, see ya in a couple minutes. Well, I got the verdict, and it's slightly disappointing. Yeah, the core clock didn't improve. It gets further into the test at 970 now. Like, previously it would just immediately fail, and now it just fails right at the end of GT1, so I guess it's slightly better, but it didn't result in a better score. Memory did improve, slightly. It can now do 2200. Well, I mean, it did 2200 before, just very rarely, and now I ran 2200 first try. However, any more than 2200, and it's gonna, like, artifact, like, real bad. It will actually, like, get pretty deep into GT1, even at 2300, but it will always fail and just artifact all over the place. So 2200 it is for the memory. So, hey, we got 100 megahertz memory clock out of it. Yay. Only cost me 16 capacitors. Yeah, and what that translated into is a 15-point score increase, because it did 4900 flat before. Now it does 4915. Yeah, not exactly very exciting. I mean, I was kind of expecting this. It's a 480, like, just, yeah. So at this point, now we've kind of established that the thing that we kind of expected. It's just like, yeah, more V-core doesn't really help that much. More capacitors don't really help that much. I could test just via EVC, giving it more voltage now, but if it didn't scale with the minimums, I don't think we're really gonna see any more scaling with, like, just more average voltage anyway, because, like, again, that's gonna drive up the temperature, and as we've established, the only thing that we really saw any scaling with here is temperature, so I don't want to increase it. So, as for the last part of this experiment here, we're gonna attach the phase change to it. Alright, everyone, I have been at this for a while now, like a couple hours, and we're reaching the point where, first of all, I think I just kind of found out where the card maxes out, and you're about to see where exactly that is. And also, secondly, it's been running long enough now, and the card isn't insulated, like, no insulations on it. And after a couple hours of running, you tend to get moisture in the memory BGA, and it tends to cause issues. But yeah, that's a pretty impressive score. So, the core is at almost 1.1 gigahertz. That is quite insane, considering that on water cooling we were at 966. This is over 100 megahertz extra. Admittedly, it's at like around minus 50 degrees, but we are very, very close to stock voltage still. I increased the voltage by 25 millivolts. I even left the LOC on because I tried disabling it and that just made the card crash. I actually made it hit OCP once. But yeah, so yeah, 480s, I remember this from the last card I had Sub-Zero. They don't really scale that much with voltage at phase temperatures. Once you go to LN2, they should scale a bit more. You should be able to push like 1.3 volts, maybe 1.4 into them and still get scaling. But I tried 1.25 volts. It's set to 1.225 right now, up from 1.21. And there I saw some scaling. It was maxing at 1075 for the core at 1.21 volts, and at 1.225 it's now doing 1090. But any more than this is not really achieving anything. I tested up to 1.25, and there's just, yeah, it's not getting any higher. Like the next step for the core clock is 1093, and that just, no chance. Like it won't even render a frame. It's just instantly gonna crash once GT1 begins. So this is a pretty hard wall. And I remember this being similar from the last GTX 480 I had Sub-Zero. Admittedly, that card was much more heavily modded. It had memory volt mod. I actually made the effort to put more Stellaris ceramics on the memory and behind the core on that card. And I think it had even more CAN-type capacitors than I put on this. And I think that card actually maxed 1080, I think. So this card's outclocking it while being modded less. So this card is for sure better than that other 480. And I think I'm gonna sub this 4HW board. This actually, is this a new high score? No. No, I got one that was slightly better earlier. But yeah, like, it's a pretty impressive score considering that I set 5,000 as like a goal for me. Went a little bit past that. I really would have liked to see 5,500, but I don't think I can really do that. Like, the card is, there's moisture traveling through the card now. It's gonna start misbehaving more and more. And also, no multi-layer ceramic capacitor mods, no memory voltage control. That's actually a bit of a huge factor because, as you can see, memory clock is still at 2200. It just did not scale with temperature at all. So, yeah. I don't actually know what the limiting factor is, because the chips usually scale with temperature, but maybe that was just the memory controller scaling with temperature the entire time. Then again, I had other cards called with other chips, and those didn't scale, so don't really know. But this card doesn't care about temperature on the memory, which, yeah, I was already kind of saw before. I just kind of hoped that the phase would just kind of force something to happen. I didn't. Actually, it got slightly worse. Like, at 2300, it now runs for less time and artifacts more than it did on water. So, yeah. Memory-wise, not much in it. So a memory vault mod would have probably helped. What would have also probably helped is a PEX rail mod. This is a thing on Fermi, on some Fermi cards. It doesn't work on all of them, but it's worth a try if you undervolt the PEX rail. Like, I think stock it's at 0.95 volts, if you undervolt that to like 0.9 or 0.85, you sometimes get slightly better core clocks out of it. I haven't done that here, because honestly I didn't expect this card to like actually produce results this good. But I guess I was right picking the card that has the worst core clock on ambient, because yeah, cards that clock like shit on ambient tend to be pretty good sub-zero, because it's usually the cards that are more temperature sensitive, so if you cool them down they just get much better. And yeah. So what else is there to say? I'm kind of surprised how well this went. I did not expect the card to get anywhere near 1.1 gigahertz. I kind of expected it to just like maybe go above 1 gigahertz and then stop. But yeah, we shot way past that. And the score is like pretty good too. Like this is... I'm gonna swap this to HW board. The only problem is this OS doesn't have Ethernet drivers and I can't validate the result. I'm gonna have to load the file on a different system and validate it there. Yeah. Is there anything else I want to say? Well, it was certainly fun doing this stuff again. Just I've had a bit of a problem lately with deciding what videos to do, because I was just like, oh, the video needs to have like proper value, otherwise it's just random stuff that I throw out there, and like I have higher quality goals now, and I don't just want to do like random stuff. I don't just want to like ramble for 20 minutes and then just have a graphics card on the table. So yeah, I want to include stuff like, you know, modding the card, extreme overclocking, and just kind of like documenting the journey, because this is the fun part. Just kind of seeing where it goes from. Like this card started at 920 core, and now it's at 1090. That's like what, like 150 megahertz? Not that much, but for GTX 480, that's quite decent actually. Like it started out as a pretty bad card, and now it's a pretty good card. Just sad about the memory. I think I remember I once had a 480 at like 2400 memory that had a volt mod. I might be misremembering, though. It might have been a 580. Not too sure, but yeah. If I decide to have some more fun with this card, I'm gonna probably at least volt mod the memory. Maybe do the packs as well, and perhaps put some extra capacitors on it, like modular ceramics. But I really don't like soldering those. They're just annoying and small, and I don't have fresh ones. I only have salvaged ones of death cards. So yeah. But anyway, I think the video's long enough now. So yeah, thank you all for watching. It was good, just doing some good old classic overclocking again. I want to do stuff like this more. Just need to pick some card to do it with. I'll go through the thing. Hey, you know what? Let's do the 4 gig RX 580, because it serves no other purpose. So yeah, I want to do the 4 gig RX 580 next. Bit more modern card, AMD instead. So yeah, I think I'm gonna do that next. And as for this video, yeah, it's probably about an hour long now. So if you're still here, really thank you, and I hope you've been enjoying this. And I've done like 3 outros now. So let's just make sure I don't do a 4th one and say goodbye.